Hi guys, welcome back to the channel. So today we are going to be discussing about the bi-weekly contest 128 second question, which is the minimum rectangles to cover the points. So we are given points which are given in the plane of this particular xy, and then we need to find the minimum number of rectangles which are needed to such that which are needed to be placed in this particular area, so that each point will be covered by at least one of the rectangle. So this particular rectangle, each rectangle has its own x1 comma 0, and then it can have x2 comma y2, which will represent the height of this particular y2 and then the end point of this particular rectangle. And then we need to make sure that it's the x2 minus x1 will be of this particular width, which will be given in the question, which is going to be integer w. So suppose let us consider one example where we have width equal to 1. That means we need to choose a rectangle in this part. These are the points, different points, and then we need to keep these rectangles, and then we need to cover all the points which are present. So suppose let us say that we have point here. Now we can place a rectangle which will be ending at this particular x equal to 4, and then we can stop at this particular x equal to 3. Now we can extend this particular bar to any height. It can be of infinite height. So we do not need to consider about the y value. So we'll be considering only the x value, which is going to be the width. So for this we are going to use one rectangle. Now when we come to this particular point, we cannot use the same rectangle which is present here. So that's why we are going to add one more rectangle which will start from here with this particular x, and then which will end at this particular y. So that is going to be our approach. Let us see the solution. Suppose let's say that we have this particular points which are present at this, and then now we are given that we can have a rectangle whose width is going to be 2. Now we'll start from here. Now if we start from here, we can go till here. So this is going to be our rectangle. It can go to infinite. Now it will cover this point, and then it will cover this point, and then it will cover this point. And then whenever I come back here, I cannot use this same particular rectangle which is present. So that's why I am going to use one more rectangle with this particular point as my starting, and then I'm going to extend this particular rectangle till width equal to 2. So this is going to be my one more rectangle which is present. So now it covers this particular point, and then this particular point, and then this particular point. Now to cover this particular point, we cannot use the same rectangle which is present. So that's why we are going to use one more rectangle which will start from here, and then we are going to use like this. So this is going to be one more rectangle. So that's why we are going to use three rectangles. So what we'll do is we'll try to sort the all the points, and then we are going to consider the x points, and then whenever we'll have the high which will store the x point of this particular rectangle, and then whenever this x width is going to be greater at this particular point, we are going to add the answer, and then we are going to assign this particular high as this particular x. So let us go through the code. So we'll be considering high, and then we'll be sorting the points so that we'll get in some particular order, which is going to be ascending order. And then we are going to consider high equal to int maximum, and then answer is going to be 0. And then we are going to consider the rectangle from starting from high. Now I have a points, this particular point. Now when it stays in this particular rectangle, then I'll not be using one more rectangle. Suppose let's say this is the rectangle, and then now I want this particular point which needs to be present in this particular rectangle. That is not possible. That's why we'll leave this particular rectangle, and then we are going to use one more rectangle with this particular points of I 0 as our high, and then we are going to increase the answer. At last we are going to return the answer. So if we come to the time and space complexity, the time complexity is going to be big of n, and then the space complexity is going to be big of 1. Yeah, that's all for this video. Thanks for watching.